A geometric series is the sum of a certain number of terms in a geometric sequence. This is expressed by the following formula, where u1 is the first term and r is the common ratio. Both these formulas are given in the formula booklet, so you don't need to memorize them. The first formula is more convenient if r is greater than 1, and the second formula is more convenient if r is less than 1. Now, let's apply this to a simple question to get a better understanding. A geometric sequence has u1 equal to 25 and r equal to 3. Find the value of S5. So here, since r is greater than 1, we'll use the first formula, which is this. So now we know that u1 is 25, r is 23. We can sub them into the formula. So S5 is equal to 25 times 3 to the power of 5 minus 1 over 3 minus 1, which is equal to 25 times 242 over 2, which is equal to 3,025. Now, in a geometric series, there's something called the sum to infinity. So the sum to infinity of a geometric sequence will either increase or decrease away from 0, or the terms will progressively get closer to 0. If the terms are getting closer to 0, then the series is said to converge, meaning the sum of the series will approach a limiting value. To calculate this, we can use the following formula, where u1 is the first term and r is the common ratio. So here, the absolute value of r is less than 1, means that r is between 1 and negative 1. This condition must be realized for the geometric series to converge to a finite value. So for example, say we have the geometric sequence 32, 16, 8, 4, 2, 1 over 2, 1 over 4, etc., where r is equal to 1 over 2. If we calculate the sum of the terms, say I list out a couple, S6, which is equal to 63, S7, which is equal to 63.5, S8, which is equal to 63.75, and we can go to 100 and beyond. No matter how many numbers in the sequence, the sum will never pass 64. And we can calculate the finite value to which the geometric sequence converges to by using u1 over 1 minus r. So in the previous example, it would be equal to 32 over 1 minus 1 over 2 is equal to 32 over 1 over 1, which is equal to 64, which was the term that I mentioned that the sums will never pass. Now let's look at a worked example of the sum to infinity of a geometric sequence. So this question asks, the first three terms of a geometric sequence are 6, 2, and 2 over 3. Explain why the series converges and find the sum to infinity. So to find the value of r, you can do r is equal to u2 over u1, which is equal to 2 over 6, which is 1 over 3. Now, since r is equal to 1 over 3, the absolute value of r is less than 1. So therefore, the series converges. So that's how you would explain why a series converges. Now, to find the sum to infinity, we'll simply apply the formula, which is u1 over 1 minus r. So now it's equal to 6 over 1 minus 1 over 3, which is equal to 6 over 2 over 3, which is equal to 9.